Okay, so we're going to solve problem solving with trigonometry. So identify angle 2 as an angle or as an angle of, guys, enough. As an angle of elevation or an angle of depression. Do the same for angle 3. Explain your reasoning. So in this case, if you guys take a look here, angle of elevation and angle of depression, think of an angle of depression as a line of sight and you're looking down, okay? You guys ever see somebody that's depressed? They're kind of like, uh-oh. You know, their heads are always down. Okay. Angle of elevation, again, line of sight, looking up. Think of an elevator, okay? But there is something specific you need to remember here. So an angle of depression is the angle formed by a horizontal line and the line of sight to the object below, okay? The horizontal line. So you are going to want to highlight this line. That's the line of sight. And from the line of sight, you're going down. Now, they don't always give you that. So you have to identify it. So that's an angle of depression. And then if we're looking here, we see an angle of elevation. So that's for angle 2. So this, again, is the line of sight. And from that line of sight, you're looking up. Again, that is not something they necessarily give you. Okay? But if they do give it to you, it's usually represented with a dashed line. So to see the person above, the person on the observation deck must look up from the horizontal. So angle 2 is the angle of elevation. To see the person below, the person on the observation deck must look down from the horizontal. So angle 3 is an angle of depression. Keyword here, keywords from the horizontal. So they're talking about you have to have that horizontal line, okay? Questions on this? Okay, so a 30-foot tree casts a 12-foot shadow. Find the angle of elevation of the sun to the nearest tenth of a degree. All right, so, okay, remember Mrs. Smith is not necessarily the best artist in the world, but let's say we have a tree here. Okay? Our triangle is going from the height to the base of the tree down from there. So we're going to have our right angle right here. They're saying it casts a 12-foot shadow. So this is our 12-foot shadow from here to here. And they're telling us that the overall height is 30. They want us to solve for this. That's what we don't know. So if this is the angle of elevation, so here's my horizontal. All right, here is it kind of looking up. What am I going to use here? Who can tell me? So just to recap, remember we have so, ka, toa. So who could tell me, what am I using here? Sine, cosine, or tangent? Well, first off, do we have a hypotenuse? Do we have an opposite? Do we have adjacent? What we got? What is it? Not quite. If we look, we have an opposite, we have an adjacent. Which one uses opposite and adjacent? Tangent. Very good. So we are going to have the tangent of x equals, in this case, 30 over 12. Now remember, we're finding an angle measure, so what do we do here? That's from yesterday. What do we put in our calculators for that? Do we just use the regular tangent, or do we use the -1? The -1. So this will be x is equal to the tangent of -1, 30/12. As long as you're in degree mode, you should get the answer, which is about what? About what? Round to like the 10th. It's asking for the 10th, actually. 68.2 degrees. Very good. Okay. Questions on that one? All right. Let's take a look at our next example. A 13-foot ladder is leaning against a house. The bottom of the ladder is 8 foot from the foundation of the house. What angle does the ladder make with the ground? All right, so here's my house. Okay, it's a pretty bad house, but that's okay. Mrs. Smith never went to art school, and that's okay. We all have our talents. All right, so there is a 13-foot ladder leaning against this house. So this is our ladder, and it's 13 feet. They're also telling me that this is 8 feet from the foundation of the house. So here's my triangle. That's 8 feet. Let me make that look a little better. There we go. All right. So what they want you to find is what angle does the ladder make with the ground? So they want you to find this. Now we have an adjacent and we have a hypotenuse. So what are we using here? Sine, cosine, or tangent? Sine, cosine, or tangent? Devin, sine, cosine, or tangent? Yeah, cosine. Very good. All right, so it's going to be the cosine of x is equal to the adjacent 8 over the hypotenuse 13. Now we're finding an angle, so we're going to take the cosine of -1 of 8 over 13. Someone tell me, what is that angle equal to? Rounded to the nearest tenth. Good. 52 degrees. Very good. Any questions on that? All right. Matthew parks his car between Karen and Patrick's buildings. The car is 35 meters in front of Karen's building. The angle from the car to the top of the apartment building is 40 degrees. Matthew's car is 45 meters behind Patrick's building. The angle from the car to the top of the apartment building is 50 degrees. Find the height of both buildings, whose building is taller, and by how much. All right, so you're looking at this and you're probably thinking, yeah, it's got to be Patrick, right? But do we always trust the picture? I wouldn't. Not in this case, but let's check it out. Sometimes it works out, sometimes it doesn't. So what we need to do is we need to find two heights. We need to find the height of Karen's building, which I'm going to label as X, and Patrick's building, which I'm going to label as Y. They give us the degree measure, so let's first look for Karen. Let's look at Karen's building. Karen and Patrick probably don't get along. But here's our 40 degrees. We have an opposite and we have an adjacent. What's that going to be? Sine, cosine, or tangent? Tangent. All right, so we're going to have the tangent or the tan of 40 degrees equals the opposite x over the adjacent 35. Put this over 1, and we're going to cross multiply. So this leaves me with 35 tangent of 40 equals x. Someone put that in your calculator and tell me about how high is Karen's building. Round to like the 100th. Good. Very good. So 29.37 feet. All right, so that takes care of Karen. Now, let's look at Patrick. All right, so again, I'm focusing just kind of in on this triangle right here. I have an opposite over an adjacent, which we already know is tangent, right? So this is going to be the tangent of 50 equals y over 45. I'm going to cross multiply. So y is equal to the tangent of 50. Should be 45 tangent of 50. So someone tell me about what is the height of Patrick's building. Again, rounded to the 100th. Anybody? Anybody? What'd you get? 53 point. I got 53.63. You got 62? What's your next digit? 45 tangent 50. Did you get an 8 next to it? So then you got to run to a 3. I thought you said 2. Sorry, never mind. We're good. You got it right. We're good. All right, so 53.63. Okay, so we know Patrick's is bigger, but they want to know by how much. So we're going to take 53.63. Subtract that from 29.37. So therefore, Patrick is 24.26 meters taller. Wait, I thought this was in feet. Or is it meters? Oh, it is meters. Whoops. My apologies. I thought it was feet. So there's our final answer. All right, let's take a look at the backside. So here's what we've got. Word problem overview. When you use the Pythagorean theorem and when do we use trig? That is the question, okay? We will use the Pythagorean theorem given sides and need to find a missing side. And when they say given sides, they're talking about 2 total sides. If you have 2 of the 3 sides, use Pythagorean theorem. For trig, given sides and need to find an angle, so that's your inverse trig. That's remember, your -1 part. And given the side and angle and need to find a side. Okay, so if you find an angle, again, you need 2 sides. And this is where you'll use your SOHCAHTOA. And this one given one side and at least one angle and the right angle. So what we're going to do now is we are going to look at these three examples. If you place a 37-foot ladder against the top of a 15-foot building, how many feet will the bottom of the ladder be from the bottom of the building? Round to the nearest tenth of a foot. So here's what they're saying. The ladder is going to be your hypotenuse. So here's 30. So this is where I'm putting 37. The 15-foot building should be landing right here. And this should be a right angle with the building with the ground, unless it's the Leaning Tower of Pisa, which is something else. And then that's the side I'm missing. So what am I using here? Trig or Pythagorean theorem? Broden, what am I using? Pythagorean theorem. So I have one leg, which is x, plus the other leg, which is 15. I'm saying that equal to 37 squared. This leaves me with x squared plus 225 equals 1369. I subtract 225 from each side. That leaves me with x squared equals, looks like 1144. And then I take the square root of each side. So in this case, x, now they wanted to the nearest tenth of a foot, is about 33.8 feet. So we're going to have to learn to set up using triangles. Just giving people a minute to catch up. What questions do we have on this? Is anybody still copying this down? Okay. All right, so it says a performer walks up a tightrope from the ground to the top of a pole that is 20 feet tall. The angle of elevation is 30 degrees. How far does the performer walk on the rope to the nearest foot? All right, so in this case, let's identify that horizontal. That horizontal is right here. So from here to here is your angle of elevation, and they're telling us that's 30 degrees. They're also telling us he's walking from here to the top of this pole. So that'll be my x, and then this will be 20. So looking at this, I have an opposite, and I have a hypotenuse. The right angle should be there, and I have a hypotenuse. What am I using here? Sine, cosine, or tangent? I don't have enough information for Pythagorean theorem. So I got to switch to trig. Someone tell me, sine, cosine, or tangent? Connor. Sine, nice job. So this is going to be the sine of 30 degrees equals the opposite 20 over the hypotenuse x. And now I'm going to solve from here. So this is going to be x times the sine of 30 equals 1 times 20. So this will be x times the sine of 30 equals 20. Now remember, this is just a number. So I'm going to divide both sides by the sine of 30, which leaves me with x equals 20 over the sine of 30. Put that in your calculator and someone tell me, what does x approximately equal to the nearest foot? Who's got it? Rebecca, what'd you get? Okay, so round it to the nearest foot. It should be, huh? You got 34.6? Are you in degree mode? I'm gonna double check. Oh, okay. Yeah, it should come out really nice. What'd you get? Are you sure you're in degree mode? What'd you get? 40 is the answer. Let me see your calculator real quick. I just want to make sure we're good. See what's happening here. Because if that's where we can correct the error immediately. Definitely degree mode. Oh, you multiplied it. It was dividing.
Oh, I did dividing the first time. I did tandem.
Oh, okay. Yeah, it's division though. Okay, good job. All right, just making sure we're good with that calculator. Okay. So, for how are we doing so far? Is there anything I can address here? Look at number 2 again, though. Is there something special about number 2 that we've already learned? Well, we have a 90-degree angle here. We have a 30-degree angle here. What would this angle be? Good. 60. Could we have, instead of doing all this, use the 30, 60, 90 rules? Yeah, right? Remember, this is our short leg. This is our long leg, which will be x times the square root of 3, and this will just be 2 times x. So that's another way you could look at this. But if you don't see it, trig still works. Okay, it gives you the same answer. Questions on that? All right. Part 3, it says Charlotte is building a skateboarding ramp that is 120 meters long and rises 120 centimeters long and rises 90 centimeters. So that means she has this. This is 90. This is the ramp at 120. What is the angle of elevation of the ramp? They're asking, here's our horizontal. They're asking for this elevation and they don't know what it is, so we're asking for it. So I have an opposite and I have a hypotenuse. What am I using here? Sine, cosine, or tangent? Layla G. Sine, very good. So this is going to be the sine of x is equal to 90 over 120. Now I need to use those inverses because I'm finding an angle. So this will be x equals the sine inverse of 90 over 120. Someone tell me, what is it approximately equal to? Again, round to the 10th. Brendan, what did you get? 77.9. You in degree mode? Okay, see your calculator? I just want to see what might have gone wrong. That's all. Okay, so this is supposed to look like this. You hit this with the sine of -1, and then it's 90 over 120. Just yeah, you just type in exactly how it looks on the screen. Okay, so now tell me what you got. Okay. Very good. Okay. And this will be centimeters. Questions? All right, I want you guys to do the you try it on your own. We'll go over it in just a couple minutes. I'm going to give you like 5 minutes just to wrap your head around it though, okay? Show hands. You're still working on this one. All right. Let's see. Iana, what'd you get for the answer? Beautiful. 29.6. All right. Who needs to see this? Okay, got it. All right. So if we line this up, remember they're telling us that the electric box is 28 feet up. They're saying that the ladder makes an angle of 71 degrees. So if this is our ladder, this is our 71 degrees. And they want us to solve for x. So looking at this, I have an opposite and a hypotenuse. So I need to use the sine of 71 equals 28 over x. Put a 1 over this, and then we just solve the proportional relationship. So this will be x times the sine of 71 degrees equals 1 times 28, which is 28. Divide both sides by the sine of 71. And then I get x is equal to 28 divided by the sine of 71 degrees. And I would just type this in my calculator as is, 28 divided by sine of 71. And then in the end, we get about 29.6 feet. Brendan, you okay? Yeah. Okay, you just look a little frustrated. Are there any questions? There's no shortcuts with this, guys. You have to be very careful, okay? And the visualization is probably the hardest part. I would tell you it's going to get easier, and it will come Algebra 2 because you'll see this stuff and you'll be like, oh, this is easy, but then you go into secant, cosecant, cotangents, and then you add graphing on top of it. So please trust me when I say you need to understand this before the end of the year, okay? But are there any questions I can address right now? Okay. Your homework is on Delta. Get going on that. And if anything pops up, please come see me, okay?